got a couple icons. Identify variables and quantities represented in a real-world problem. Write the system of equations that best models the problem. Solve a system of two equations and two variables by elimination and/or substitution. Infer that since y equals f of x and y equals g of x, that f of x equals g of x by the substitution property. Infer that the x-coordinate of the points of intersection for y equals f of x and y equals g of x are also solutions for f of x equals g of x. And last one, identify linear systems that have no solution or infinitely many solutions and explain why. Ready to tackle them? Yeah, this is fun, you guys. Get pumped. It's so much fun. All right. Sometimes when we graph, it's not so obvious. You're kind of like, well, it looks like this, looks like that. So instead of guessing, we use substitution. Okay? These rules, I would star, highlight, circle, whatever. First we're going to do is solve for one equation for one of the variables. Then substitute it into the other one and solve for that one. And plug them back in. Okay? Sounds like maybe you guys are familiar with this stuff. What? Yes, no, maybe so? Oh, too far. Alright, so what I like to do, we have a system 2x plus 4y equals 12 and 2x plus y equals 10. I like to find the easiest variable to solve for as possible. So like in this instance, y doesn't have a coefficient attached to it. So it's probably the easiest one to solve for, so that's what I like to solve for. Keep it easy peasy. So if I want to get y by itself, what do I have to do with 2x? Subtract it. So this becomes y equals negative 2x plus 10. Okay. Now all we're going to do is plug this stuff in for our y in the other equation, okay? We don't want to use the same one, otherwise we're going to get nonsense, okay? So then what we do is we copy down the equation until we get to the variable that we replaced. So 3x plus 4, instead of y, I'm going to write this red circle stuff. I always write parentheses so I remember to distribute, stuff like that. So negative 2x plus 10. And then jump back to that top equation, finish it off, equals 12. Okay. Oh, what is that? Questions on why we put stuff, where we put stuff, etc.? Yeah, coffee and blood. Okay, to solve, we're just going to distribute. So we still got our 3x. If I take 4 times the negative 2x, how much x do I have? Negative 8x. And then 4 times 10 gives me positive 40, still equaling 12. Okay. So now I just got to simplify, combine like terms. 3x plus the negative 8x gives me negative 5x. Now what do I have to do? Subtract 40 from 12. So I get negative 5x equals, guesses? Negative 28. Then what do I have to do? Divide by negative 5, and we get a nice number of 5.6. That's an X. So we're feeling like it's maybe a little bit sketchy. We got a decimal, I'm not so sure about decimals.
Oh, that's not bad.
That's not bad? I'm glad you think that way. Alright, I have X, I need Y. So you can plug it in a bunch of different places. You can plug it in here, or here, or here. I like, since Y by itself there, I just like to plug it in right back into there. So we got y equals negative 2. Our x, we said, was 5.6 plus 10 plus 10. And then that simplifies down to negative 1.2. You all know how to use a calculator, right?
No.
What? Wise.
Did you go to his?
No, my dad did. Look at how much green there is here. It's like it's St. Patrick's Day. Alright, we're not done yet. How do I know it's right?
Plug it in.
Plug it in. Check it. So, should I check it in just one?
No.
No, both. Okay. So we got lots to do. So we got, I'm going to square this off here. My x 5.6, y is negative 1.2, so I got 3 times 5.6 plus 4 times negative 1.2 equals 12.
Yes.
It does? Good. So it works on the top one, we gotta make sure it works on the bottom one too. So 2 times 5.6 plus a negative 1.2 equals 10. Yeah. Sure does. So then we gotta write our solution as a point. So much writing, so much work, but so much fun.
Well, actually, you don't have to check your work if you're smart enough to not make a mistake.
Check your work. So our answer 5.6, 1.2.
Just understanding this.
Check your work. Alright. Questions so far? Feeling okay? Only like 80. Just kidding. No, not seriously. Alright. Oh, you can't even see it up there. You can see it on your paper. Which one do I want to solve for? Top or bottom? What variable on top? X, yeah. Easy way out. Glad I taught you guys good. Get x by itself, I get x equals negative 3y plus 5. What do I do now?
Plug it in for the minus 2x.
Yeah, plug it in the bottom. This stuff is going in for this x right here. So I have negative 2 times negative 3y plus 5 minus 4y equals negative 5. Now what? Distribute. So I get 6y minus 10 minus 4y equals negative 5.
Maybe negative. Be negative.
Did I make a mistake? Negative 2 times 5 is negative 10. Okay. Alright, simplify. I'm going to do it in one step. 2y equals plus 5. And then y equals 2 point. What?
5.
How would you get plus 5? Oh, shoot.
Minus 5 plus 10.
Oh, yeah, okay, never mind.
Are we still good?
Yeah.
Did I make a mistake?
No.
Okay. Probably
Probably.
what?
I'm getting.
So we got y. Am I done?
Nope.
What do I gotta do?
Find x.
Find x. Plug it in. Take 2.5. Plug it in for y right here. So x equals negative 3 times our 2.5 plus 5. Get you a calculator, and x equals negative 2.5.
We have to check it.
So I'm not done yet?
Mhm.
No, we gotta check it.
You don't have to check it.
No, I mean, that's kind of up to you to risk it. But you don't have to show it if you don't want to. I'm gonna show it because I like to show my work. Because I'm a good kid. Just kidding. What? Negative 2.5 plus 3 times 2.5. Does that equal 5? Yeah. And then the bottom one, negative 2 times negative 2.5 oopsies, minus 4 times 2.5 equal -5. It sure does.
Raise up -4.
Minus 4 times, yeah. So since it works out, I put my answer in an ordered pair, which is -2.5, comma, 2.5. Yes, sir.
How come is it +5 and -5?
Because that's where our stuff is here.
Oh, okay.
You tired yet?
Yeah.
That's okay, we only got one more. Questions?
Let's get the next one.
No.
Yeah.
You can take a nap when you get home.
No, you out.
Oopsies, we must be down. There we go. Alright, music stores offer piano lessons. Cost for lessons and a one-time fee for materials, including music books, CDs, software, etc., are shown in the advertisement. I want to know what the cost of each lesson is and what the one-time fee is. So, let's have X be how much a lesson costs. So, like, money per lesson. Does that make sense? Because I want to find out the cost of each lesson. And then Y is going to be our one-time fee. Okay. So, I know over here in this advertisement that 6 lessons cost $300. So my grand total is $300. So 300. I want to know what goes into that $300. I know I get 6 lessons, but I don't know how much they cost, right? So 6x plus my one-time fee, which is what? Then our other one for 12 lessons costs $480. So 480 equals this one. I got 12 lessons, but I still have that one-time fee. So we have 480 equals 12x plus y. Okay, are we good there?
Maybe.
Maybe. I feel like that's not a non-committal answer. Alright, now we just gotta solve. So, y is by itself both places. Let's just do it up top. So if I get y equals -6x plus 300, and then plug that in
Negative.
for here. Do what? Okay. So then we got 480 equals 12x plus -6x plus 300. Simplify, we still got 480 on the left. 12x minus 6x gives me 6x plus 300. Then what? Subtract 6x equals 180. How much is x?
30.
30.
And you also have to put a dollar sign.
How would you get 380?
Say what?
How'd you do it?
Which from where to where?
Are you 112 by 300?
So this is 12x plus, this is all what we replaced with y. So then we just have 12x plus a -6x, which is just like subtraction.
I did it
And then we still have our 300 out at the end. Am I done?
Yeah.
No.
No. Gotta plug my x back in. y equals negative 6 times 30 plus 300. So y is 120. Dollar sign.
You gotta just check the other two.
Yeah, we're gonna check that one. Alright, plug it in. What is 6 times 30? 180. What's 180 plus 120? 300. This one works. How about 12 times 30? Big number.
360.
360 plus 120. So the cost per lesson, $30, and our one-time fee, $120. Expensive. Don't take piano. All right. Questions? None.
I don't have